Hello, Rodney Carr here. Glad you could join me. I'm going to demonstrate an easy way for you to carry out statistical analyses of data. Yes, I know there are lots of textbooks and other resources for learning statistics out there. What I'm going to show you here is how to make the data analysis part simple. Then you can concentrate on other things like designing your experiment or your survey to collect the data the best way you can for your investigation. That's the real work of statistics. It's not the data analysis. So let's make the data analysis as easy as possible. What I'm going to show you is how a lot of data analysis depends on getting the data organized nicely in the first place. If you do that, a lot of the appropriate analyses are determined to a pretty large extent. I'll also show you how it works using a data analysis tool called XLStatistics. XLStatistics is a set of Excel workbooks that you can download for free from this web page. You scroll down a little bit and you'll find a zip file that you can download, save to your computer, and extract all of the files it contains to a folder somewhere. Here are the extracted files in a folder on my computer. There are lots of them, but you only need to open up one file, the one that's very last on the list, called XLStats.xls. So you open that up. Excel warns you that the file contains macros. If you want to use the package, you have to click Enable Macros, and then you get this Launchpad. Now let's start talking about what I said at the start. Appropriate analyses of data depend to a large extent on getting the data organized nicely in the first place. This Launchpad displays one of the basic ideas behind this, that data contains two types of variables. A variable is just something just a quantity that you've measured. There are two types of variables. There are ones that are called numerical variables, and there are ones that are called categorical variables. Numerical variables are ones that are measured. When you measure them, you get a number, like temperature, or a person's weight, or a person's income, or their age in years. They're all examples of numerical variables. Numerical variables are sometimes called quantitative variables. The other type of variable is a categorical variable. When you measure that sort of quantity, you don't get a number, you get a label. Like, if you measure things about people, you might get their age, that's a numerical variable, but you also might get, well, city where they live, or their educational level. Or if you measure something about a plant, you might get its age again, or you might get its species. Categorical variables, they're labels. Categorical variables are sometimes called qualitative variables. So a first basic principle of data analysis is that the analysis depends to a large extent on the number of variables that you're working with and what type they are, numerical or categorical. XLStatistics has the analyses organized in this way. So, for example, this workbook here, 1num, contains analyses appropriate for a single one numerical variable. This one here, 1num, 1cat, handles analyses for two variables, one numerical and the other one categorical, etc. These buttons, when you click one of those buttons, they provide access. They access the corresponding workbook. So let's do a problem, and I'll show you how it works. Actually, we won't use this Launchpad. It's not a bad way of seeing how the analyses are organized in Excel Stats, but it's almost always not the best way of accessing the workbooks. They're best accessed from this here Excel Statistics menu. You see it's got all of the same items as the Launchpad. It's just easier to use the menu. You get the menu when you open up the workbook, and it's easier to use it usually than the Launchpad. So let's just hide the Launchpad and do our problem, and we'll access the files from the menu. Here is our problem, or rather here is the data for our problem. The problem is that in a firm, employees of the firm are being trained to carry out a particular task using one of two methods. The methods are method M or method T, and it's believed that method M is superior to method T in the sense that after the training, the error rate of employees carrying out whatever task it is lower under method M than it is under method T. And in column B here, we've got the error rate of the employees. This data is organised in that nice way that I was talking about before. Each column contains the measurements of a different variable. So the nice way of organising, one of the features of organising data in a nice way is to have your variables, the quantities that you measure, in different columns. So we've got here column B contains the error rate of employees after the training. Method D, the column D here contains the method that was used to train up the employees. Column C contains the age of the employees. We're just going to ignore that variable in our analysis, but you can typically have in data sets, you'll have extra variables that you might not be interested in at that particular moment. They might be used in analysis later on. You also often have variables like this one here in column A that isn't really a variable at all. That's just a label for the employees, it's employee number. So that's one of the key things of organising data. Variables go in columns. Each row, you've got row-wise, the first row of the data is a header row that contains the name of the variables, and then each row underneath that contains data for a particular set of measurements for a particular case. In this case, each row corresponds to a set of measurements done on an employee. It's their error rate and their age and the method that they were trained up to use. Alright, so let's analyse this data and answer our question, does error rate depend on method? So we've got a numerical variable and a categorical variable. We're going to use one num, one cat to analyse it. To do that, you just highlight all of the data that just make sure that you highlight the variables that you're interested in. Doesn't matter if you've got other variables. We've got age in the middle here that we're just going to ignore for this analysis. We need the variables in column B and D. So then we go to the XLStatistics menu and we pick the appropriate data analysis workbook, one num, one cat. There it is opened up. That is now, we're now looking at one num, one cat. The data has been imported over here into columns A and B into an area called the data area, and we get to pick our variables now. If necessary, you have to use these little drop down boxes. In fact, we have to in this case. You can see the little n here, the little n, that indicates that that's the column where the numerical variable that we're analysing is to go, and this one's correct because it already is our numerical variable, so we don't have to do anything. But this one isn't. That little C there indicates that's the column where the categorical variable is supposed to go. So let's pick our categorical variable from the drop down box. It's not age, it's method. And now the rest of the workbook has the analysis appropriate for that combination of variables. Lots of different types of analyses that you can now pick and choose from in order to help answer the question. We'll do that in the second movie. Bye for now.